Hi, this is Alex from devstories.eu. Prompt Flow, the Complete Guide, episode 14 of 14. You have built, traced, and evaluated your language model flow, and it works perfectly. But right now, it is just sitting in your development environment, completely isolated from your actual users. Getting it out of your IDE and turning it into a stable, reachable service is exactly what we are covering today by taking flows to production. At rest, a prompt flow is simply a folder. It contains a configuration YAML file and your Python scripts or Jinja templates. To make that folder do anything in the real world, you need an execution environment to load those files and listen for incoming HTTP requests. During development, you probably used the local built-in server. You run a simple command and it spins up a local endpoint to test inputs and outputs. This is fine for verifying logic, but it is not designed to handle concurrent production traffic, manage memory efficiently, or survive a system crash. To reach production, you need containerization. Prompt Flow is built to integrate directly with Docker. Instead of writing your own web server from scratch, you use Prompt Flow tooling to export your flow as a Docker container. When you run the export process, the system generates a Docker file. This file defines a base image, copies your flow directory into it, installs the exact Python dependencies listed in your requirements file, and sets up a production-ready web server to serve the flow as a REST API. This is the part that matters. Once your flow is in a Docker container, it stops being a special machine learning experiment and becomes a standard software artifact. You can treat it like any other microservice. Take a concrete scenario. You have a validated customer support chat flow. You build the Docker image and push it to your private container registry. Next, you deploy that image to a Kubernetes cluster. You write a standard deployment configuration telling Kubernetes to spin up 3 replicas of your chat flow container, and you place a load balancer in front of them. Now your front-end application sends standard HTTP requests to the load balancer, which distributes the traffic across your containers. If your chat flow gets slammed with user requests, Kubernetes simply scales up more instances of your flow. If you do not want to manage a Kubernetes cluster, that same Docker image works perfectly on managed platform services. You can deploy it directly to Azure App Service or any other cloud provider that hosts containers. The flow does not care where it runs, as long as it has a container runtime. There is one alternative deployment pattern. If you're not building a web service, you can distribute a flow as an executable application. This packages the flow and its runtime dependencies into a standalone executable file. This is useful if you need to run the logic directly on a client machine or an edge device, entirely bypassing the need to install Python or set up a server. Moving a prompt flow to production does not require proprietary hosting or specialized machine learning infrastructure. By exporting to Docker, your language model flows integrate seamlessly into the exact same continuous delivery pipelines and container orchestrators you already use for your traditional backend services. If you want to take this further, I encourage you to read through the official prompt flow documentation, try deploying a container yourself, or visit devstories.eu to suggest topics you want to see in future series. I would like to take a moment to thank you for listening. It helps us a lot. Have a great one.